So this past week, Sarah members Rich, Jay, and Ted walked into a bar and we had lunch and we talked about big things. I mean, big things, galaxy things. Here's a picture of the galaxy. You can see the galactic center here. Here's the sun down on the lower side, and we can see all kinds of arms on here. I've collected some radio data that tries to represent those arms. Does the data support the arms? So this screen comes from another one, which has the sun in the center. And you can see that looking out at different galactic longitudes, there were a lot of measurements taken at 1420 megahertz. But there's a bunch of data that's missing over here on the side. The data that was used was collected right along the galactic plane, shown by these green dots, on the galactic plane, shown by the red dots. But still, down on the bottom, there's a part that the telescope cannot see. The Earth gets in the way. The easiest way to collect data is with drift scans, where you point the telescope up at a certain location of the sky and just start recording. Eventually, it will draw a line across the sky, measuring the power received. You can see there are two bumps here where the power is higher than others, where it crosses the galactic plane. And we can use those points where it crosses the galactic plane. If you do that again and again and again at different telescope elevations, you start to paint the sky. We get bumps all along about the right places. Eventually, you get data for that galactic plane, shown by all these green dots. But again, there's data missing down here on the bottom. Up in Colorado in the USA, this motored dish, LTO 15, standing for 15 foot, can see the sky from all the way from Polaris up here at the North Pole down to where the Earth gets in the way. Another telescope, LTO 16, with no motors, can collect a lot of data, but it has trouble turning around and facing to the north. A telescope in Darwin on the north side of Australia could almost see the whole radio sky. And another telescope in Christchurch in New Zealand could see the southern sky quite easily. So Rich, Jay, and I were discussing maybe there should be an organized project to collect data and share it among members. We can't spell very well, so we came up with SHOOS, standing for Sarah Hydrogen Observing Overall Survey. To collect data for the survey, you would need a 1420 megahertz antenna with a low noise amplifier, some kind of USB radio, like the inexpensive RTL SDR USB dongles, and then plugging that into a data collecting PC. The PC can be old, but do set the clock to some local time zone or even to coordinated universal time. There is free software for Windows or Ubuntu Linux. That free software is the Easy Radio Astronomy, or ESRA's Easy Call, call standing for collect, and that's run on Python. An alternative is to use the scope in a box method with SDR Sharp and the IF average plugin. But I think that has a limit of collecting just 2 days of data without pushing more buttons. The whole idea is to collect a lot of drift scans. You might start with the telescope pointing north at azimuth 0 and pointing up a bit at 45 degrees elevation. I suggest each week you go out there and change the antenna elevation, maybe one beam width, a little bit towards the South Pole each time, and then run the program again. Collect more data. Each time you record data, please record the elevation either inside the file or in a log or in a file name or a directory name. The daily data files are about 5 to 12 megabytes, although the directories can easily be compressed into zip files. There are fancier methods, but I just use a USB thumb drive to move the files about. Eventually, we'll collect them into a Sarah Dropbox, maybe, or maybe use Google Drives on the web. One of those alternatives was Ezra, the Easy Radio Astronomy, and here's the web page for that. If you do use Ezra, it runs on command lines, and they can get long with all the different parameters. One easy way is to take all those unchanging parameters and put them in an easy defaults.txt file, much like this, where you spell out the name of the observatory, maybe in Perth, maybe a 3-meter dish, the latitude and longitude of where that telescope is, and its altitude above mean sea level in meters, please. I suggest you collect reference samples, and that lets the program compare galactic hydrogen frequencies to non-galactic hydrogen frequencies. No hydrogen should be up at 1423 megahertz. Sometimes the telescope will be pointing to the south at 180 degrees azimuth, and sometimes it might be pointing north. If you have two parameters like this, the last one in the file wins. And so eventually every week you would run a command like Python and go find the easy call program, and then tell what elevation you're recording. In this example, 45.3 degrees above the horizon. So please consider participating in this project, SHOOS, standing for Sarah Hydrogen Observing Overall Survey. And here's a link to some of that software.